Everyone, welcome to questions on configuration and bonding. So to start us off, we have got to write the electronic configuration in terms of subshells of an Fe2 plus ion. Okay, so got to be a little bit careful when we do this, because normally we'd start with something like this. You start with the actual element itself, ion. You can go to your periodic table and get this information. Fe is 56 and then has an atomic number of 26. So if you're going to draw out your configuration, now you can do this if you want to keep things simple, because sometimes people get a little bit confused when they're putting configurations together. You can write out your configuration as normal, and then you can take into account the 2 plus. Now in order to become positive, you have to lose negativity, and it's the electrons that are negative. So therefore, if we're 2 plus, we must have had to lose 2 electrons. So we have 2 less than we have for our Fe2 plus. So if that's the case, we should have 1s2, 2s2, 2p6, 3s2, 3p6, 3d6. That's what we should have for that, the Fe2 plus ion with those 2 less electrons. Right, then we have the second part, draw a dot and cross diagram for FeS2, show outer electrons only, worth 2 marks. Okay, so just in case we might have forgotten, it has told us up here that it is an ionic compound, because iron is metal and sulfur is non-metal, so metal with a non-metal is ionic bonding, just in case we forgot from GCSE. So we need a transfer of electrons from the Fe to the sulfur, the S. But bearing in mind we have 2 sulfurs, and this is where things have obviously taken it a step further from GCSE. We need to show the 2 sulfurs bonding together covalently, still taking into account that the ion has donated electrons to it. So that's a little bit we have to then sort of add in there. So if I'm starting this off, I'd say that sulfur is in group 6, and I've got 6 electrons in its outermost shell. So that is going to take that into account for me. So I know I've got 2 S's, both non-metals, covalently bonded together, shared pair of electrons, and then I have the remaining electrons for those. Now, how do I know how many electrons that ion has donated? Well, it has said at the top of the question here, again, always got to read the question, highlight things where you can. We have Fe2 plus ions, we have S2 minus ions. So that means that the ion has donated 2 electrons, and the sulfurs have gained 1 electron each. Then overall it becomes then 2 minus. So we're showing outer electrons only, so we have just our Fe, our ion in a square bracket with a 2 plus charge donated 2 of its electrons. We have our sulfurs covalently bonded together with a shared pair of electrons, and now we have to have some sort of third symbol. So squares are quite a common one to use, maybe triangles if you want to show those electrons are different. You have dots for one sulfur, crosses for the other sulfur. We then need a third and a different symbol to show that those electrons have come from somewhere else, that somewhere else being the ion. So that's just showing you there in writing, got to be shown differently from the Fe. Okay, final question. We've got some relative isotopic masses and some abundances. It says, what is the relative atomic mass of bromine in this sample? Answer to 3 decimal places. Just want to emphasize that it's 3. It's in bold, but again, we see people time and time again not putting it to the appropriate degree of accuracy. So, as we'd expect, nice and straightforward. We set up as we normally do for one of these questions, so we take the mass and we're going to times it by the abundance, keep that in a bracket, plus the mass of the other sample that we have, times by the abundance, keep that in a bracket, and then divide by 100. If you're going to put it all in your calculator in one go, that's fine, just make sure you got your brackets and it's all good. But we should get an answer that is that there. But we need answers to 3 decimal places. If you don't do that, you can lose a mark. And then finally, we have to then write an electronic configuration in terms of the subshells for an atom of bromine. Now, if I'm doing this, I'm going to a periodic table, I'm finding bromine, I've got 79.9 and I've got 35. So that's 35, 35 protons, 35 electrons, and I've got 35 electrons to be dealing with, and I've got to put those into the shells. So therefore I've got the 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, then 4s2, and then I've got 4p5 to finish that off. And if you add up all those numbers that are superscript there, they should add up to giving you 35. Okay, so hopefully that's okay for questions on configuration and bonding. See you next time.